Good morning, students. Welcome back to the class. So successfully we have finished a few chapters already. We have done with differentiation, relation functions, inverse trigonometric functions and matrices. So these are the 4 chapters we have finished. Our next chapter is going to be a chapter which is based on matrices only. That means it's a continuation of matrix, okay, but we will study only a particular type of matrix in that one, okay. So the next chapter is purely based on square matrix. That's one hint I can give you, okay. So apart from that, hope all of you are practicing with the home exercise, okay. And yes, I'm happy few of you are texting me, and if there are any doubts or clarification, and most of you are sending me a picture, telling me that sir, I'm unable to understand this, so please explain. So whoever is sending, I'm just trying to explain my best, and the response is quite good, so I'm happy with your response. So once you start studying, once you start practicing, of course you will get some doubt, okay. So that is a hint actually. Yes, the students are getting familiar with the topic, the students are getting used to the topic, okay. So if there are any doubts, clarifications, so please contact us, okay. So today let me start with the next chapter. We call it as determinants. So what is a determinant? Okay, so before I start the definition, so I should go back to the definition of function first. So I'm going to start with the definition of function. So let me consider a function f from a to b. So f is a function defined from set a to set b. What is a here? A is set of all square matrices, maybe of any order, maybe of order 1, order 2, order 3, order 4, maybe of any order, okay. So A is a set which contains all the square matrices, first thing. And what does B stands for? Now the set B stands for real numbers. So this is the beginning which you have to remember. So there is a function f from a to b where a is a set of all square matrices, b is a set of all real numbers. So if I start representing like the arrow diagram, so f is a function from set a to set b. So what are here? Square matrices, correct? Now, for example, there is a square matrix A, square matrix B, C, D and so on, correct, right? And here there will be real numbers. So what happens if it's a function means, when will we say it's a function? If every element of A is associated to a unique element in B, correct, right? Now here what is the meaning? If every square matrix should be associated to a real number, then only this will be called as a function, right? That means every square matrix will be associated to a real number, correct, right? Every square matrix associated to a real number, correct? Now that unique real number is called as determinant of the matrix. So that's the definition what we are looking for. So what is a determinant? Okay, the real number associated with the particular square matrix is called the determinant of that square matrix. That's the definition what you have to remember. So determinant, a simple definition: if there is a square matrix, then that square matrix is associated to one particular real number. That particular real number is called as the determinant of the square matrix. So if I start A is a matrix, usually matrices are denoted by alphabets, capital alphabets, right? So if A is a matrix, determinant of the matrix, short form det A they will write sometime. The standard form is writing this. A is written within a pair of vertical lines. Please do not get confused this with absolute value. We use mod function, right? Please do not get confused with absolute value or the mod value of the function. No, not with that, okay. So this symbol you should not mix up with the absolute function or the mod function. This symbol in determinant, so in matrix, this symbol stands for determinant of a matrix. So if A is a square matrix, det A or determinant of A is denoted by this symbol det A, okay. The way of reading that symbol, determinant of A, okay. So don't read it as 2 vertical lines and A inside, not like that, okay. So this symbol stands for determinant of A. That's a short form of writing a determinant. Clear, students? Okay. Now let's come back to the definition once again. So every square matrix is associated to a particular real number, a unique real number. That unique real number is called as the determinant of the matrix. That's the definition what you have to remember. Hope the definition is clear. Then, given a square matrix, how to find its determinant? Let me explain you this. Okay, so first let's consider a square matrix of order 1 cross 1, 1 by 1. If you remember, this is a square matrix of order 1 by 1. Its determinant is denoted by this, right? And whatever the matrix is there, no, the matrix should be converted to determinant. So determinant A 1 1. Correct now? So what is the real number associated with this? Quite simply, the single element, whatever is there, that itself is called as the determinant of the square matrix. I know you will get confused because of that, but most of the things we will never study any square matrix of order 1 by 1. Okay, so it's easy actually. If given a square matrix of order 1 by 1, okay, its determinant is nothing but the element which is present in the matrix. That's all. Then, given a square matrix, if you want an example for this, if A is a square matrix of order 1 by 1, the element is 2. What is the determinant of this? Determinant of this simply nothing but 2. Now let me consider a square matrix A of order 2 by 2. So A11, A12, A21, A22. This is a square matrix of order 2 by 2. Its determinant. So first you convert from matrix symbols to determinant symbol by writing this A11, A12, A21, A22. So matrix is converted to determinant. So how to find its value? What is the unique real number associated with the square matrix? Now to do that, first thing, you multiply the left diagonal elements. So what are the left diagonal elements? A11, A22, correct, right? Minus. Now multiply the right diagonal elements. So what are the right diagonal elements? A12, A2, correct? So to find or to evaluate a determinant of order 2 by 2, first thing, multiply the left diagonal elements minus right diagonal elements. Now this question here, sir, why this has to be a minus sign? Why it cannot be a plus sign? This should arise. Okay, now simply don't consider whatever I say. Okay, you have to think once, why a minus sign, why not a plus sign? And that is because every square matrix of 2 cross 2 is associated with particular signs. This we call it as sign matrix. This we call it as sign matrix. The sign which is associated to each element are plus, minus, minus, plus. Okay, now that was the reason why we say left diagonal. Now see, I am trying to expand from the first row. I can expand it even from the second row also. Since I am expanding from first row, the signs associated are plus and minus. So that's why left diagonal minus we will write, then the right diagonal. So with the help of the sign matrix we will expand actually. Okay, the sign associated with the first row is plus and minus. That's why we say left diagonal minus the right diagonal. Okay, sir, what if I suppose want to expand it from second row? This is expanded from first row, right? Okay, I will explain everything with an example so it's better. So let me take an example. Let's consider a square matrix A 1, 2, minus 2, 3. It's a square matrix. Now the first case, I will expand it from first row. I will expand it from first row. So the determinant will be equal to determinant 1, 2, minus 2, 3. So what you do is, you take the help of the sign matrix. So on the top of the first row, you write down the sign. The top of the first row sign is plus and minus, correct now? So let me expand it from the first row. So this already plus sign, so 1 multiplied by 3 will be 3. So what is the next sign? Minus. You write down the minus first. Then look at here. This is over, right? Now multiply these two. 2 multiplied by minus 2. That is minus 4. So what's the answer will be? 3 plus 4 will be equal to 7. This I expanded from first row. Now the next case, let me expand it from second row. I want to expand it from second row now. So the same determinant will be expanded from second row. So 1, 2, minus 2, 3. What are the sign associated with the second row? The sign associated with second row is minus plus. Correct now? So what is the expansion is going to be? First I will multiply. You can multiply actually the right diagonal also, it doesn't matter, but you have to take care of the sign, that's all. Clear? Now let me expand it the left diagonal first. So the left diagonal, it's associated with the plus sign, so 3 multiplied by 1 will be 3. Look at that. The next element, before expanding, before I multiply these two, I will write down this sign. Then 2 multiplied by minus 2 will be minus 4, and now the answer is still going to be 7 only. So let me expand from first column and second column. Certainly we will do it. Okay. So in the third case, first column I want to expand it. So it's going to be 1, 2, minus 2, 3. What is the sign associated with the first column? Plus and minus. Look here, the sign associated with first column. So I want to expand it from here. Clear, students? So how to expand it from first column? Again, see, this element is associated with plus sign. So plus 1 multiplied by 3, it's going to be 3. Next, this element is multiplied by minus sign. So write down the minus sign. Minus 2 multiplied by this. So that's going to be minus 4. Answer is still going to be 7. So we expand it from any row or any column. The value still remains to be same. The only thing is you have to remember the sign matrix of order 2 cross 2. This we call it as sign matrix of order 2 cross 2. So with the help of the sign matrix, we'll go with the expansion. So right now what I suggest, you please remember expand from first row always. But remember students, you can expand it from any row or for any column. The value still remains to be same. Just look at here. So this is a square matrix. It's associated. What is 7? 7 is a real number. This is a square matrix. Correct, right? Then this 7 what we got here, this will be called as determinant of the matrix A. So denoted by determinant of A is equal to 7. So like that, every square matrix is associated to a unique real number. That unique real number is called as the determinant of the square matrix. So it is denoted by this symbol. This is not to be get confused with absolute value or the modulus value. Fine, students? Okay. Now we studied about 1 by 1 determinant. Now we studied about 2 by 2. Now let us go and study 3 by 3. Okay. The whole chapter we'll just going to study about square matrix. That's all the thing which you have to remember. Okay. Determinant cannot be studied for every type of matrices. It is studied only for square matrices. Okay. Square matrices will include even what? Diagonal matrix, scalar matrix, unit matrix, all those are allowed. But wherever you got orders are not same, like just like not 3 cross 3 or 4 cross 4. So you cannot study a determinant for 2 cross 3. Or you cannot study a determinant of 3 cross 4, something like this. So determinants are purely studied for square matrices. Okay. So I explained you how to find a determinant of order 1 by 1, how to find a determinant of order 2 by 2. Now let's go and check how to find a determinant of order 3 by 3 now. So the third case, it's better if I explain with an example. So 1, 2, minus 1, 3, 4, 2, 1, minus 1, 2. Look here. So this is a determinant of order, matrix of order 3 cross 3. What is the sign matrix associated with this? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So that means in a square matrix, every element is associated with one particular sign. So this we call it a sign matrix. With the help of this, I can go and expand it from any row or from any column. I will just give you a few examples. So one of the case, let me go for first row. I want to evaluate this determinant from first row. So first convert the matrix to determinant. 1, 2, minus 1, 3, 4, 2, 1, minus 1, 2. It's a determinant. See, matrix is converted to determinant. I want to tell you one important thing here, students. In case, see, matrix, you have to use only this, otherwise you are allowed to use this, correct? No? Determinant, you have to use 2 vertical lines. In case, while solving a problem of determinant, instead of this symbol, most of the students will write it like this. No marks will be given. This happens, most of the students will do this. Okay. So if it's a determinant, it has to be a determinant symbol. If it's a matrix, it has to be a matrix symbol. But there are many occasions we have seen in the final examination also, okay, where students will interchange matrix and determinant symbol. Marks will not be given. It will be given as 0. In case, while setting the paper, if the paper setter, instead of matrix, he writes a determinant symbol, or instead of determinant, he writes a matrix symbol, okay, you will be given grace marks. You have to remember this thing. So let this happen. This will happen. Sometimes intentionally they do. Okay, let this happen. But I don't want my students to go wrong while writing the matrix or determinant symbol. You cannot interchange these two. It should be kept in mind. Okay, so please don't try this at all. Okay, so let us go and expand it from first row. I said, correct now. What are the sign associated with the first row? Plus, minus, plus. How to expand it? Quite simple. What is the first element? First element is associated with plus sign. So write down 1 as it is. Fine. Then just leave the column and row in which that 1 is present. It's an element of first column and first row. Block these two. So when I block these two, what are the remaining? Actually, remaining are going to be these 4. And these 4 are a determinant of order 2 by 2 now. So what we are trying to do, from order 3, we are reducing it to order 2. So determinant, what are the remaining elements? 4, 2, minus 1, 2. Correct? Now go to the next element. The next element starts with minus 2. Minus 2. Again the same thing. Block the column and row in which that element is present. What are the remaining elements? 3, 2, 1, minus 2. Correct, right? So determinant 3, 2, 1, minus 2. And look at the next. The next element is associated with the plus sign. So plus multiplied by minus is going to be minus determinant. It's 1 actually. So leave the column and row in which that minus 1 is present. What are the remaining elements? The remaining elements are 3, 4, 1, minus 1. So what we did was, we reduced it from order 3 to order 2, and I already know how to expand a determinant of order 2 by 2. Right? So let's go and expand it. So if I want to expand it from first row, I should write down the signs on the top of the first row. So my first element is 1. Open the bracket. Okay. So multiply the left diagonal. 4 multiplied by 2 will be 8. And minus, first write down the minus sign. Then 2 multiplied by minus 1 will be minus 2. Left minus right. That is what you have to remember if you are expanded from the first row. So just remember in this way. Left minus the right. Left diagonal minus the right diagonal. Fine. The next, minus 2. Open the bracket. Multiply the left diagonal first. 3 multiplied by minus 2 will be minus 6. So write down this minus first. And now multiply these two. 2 multiplied by 1 will be 2. And let's come to this. Minus 1. Open the bracket. Multiply these two. Minus 3. Minus, which is here. 4 multiplied by 1 will be 4. Close it. Let us go and simplify these elements. So 1 multiplied by 10. Minus 2 multiplied by minus 8. Minus 1 multiplied by minus 7. Let's simplify this. So 10 plus 16 plus 7. So this is 26 plus 33. Got it? So what is this? It's a real number. It's a real number associated with what? It's a real number associated with this particular square matrix. So this real number is called as the determinant of the square matrix, denoted by this symbol. So like that, every square matrix will be associated to a real number. That particular real number is called as the determinant of the square matrix. What we did is we expanded from first row. Now let me go and try. Let me expand it from first column. Now second case, I said I'm going to expand it from first column. Fine. So let's consider 1, 2, minus 1, 3, 4, 2, 1, minus 1, 2. What is the sign of the first column? The sign of the first column is plus, minus, plus. Write down there. The concept remains the same. I want to expand it from first column, right? First element is multiplied by 1, so plus 1, right? So concept is the same. Leave the column and row in which 1 is present, and consider the remaining 4 elements. The remaining 4 elements are 4, 2, minus 1, 2. Clear? Look at the next. The next element is minus 3. So write down minus 3. Right. And now you block the second column, so first column and second row, where 3 is present. What are the remaining elements? The remaining elements are 2, minus 1, 2. Remember, already we know the value. The value of the determinant of this from expanding from first row it is 33, right? Now, let us go and check this now. Now, what is the last element? The last element is plus 1. Now, the concept is same. Leave the column and row in which that element is present. So that means these two will be blocked. What are the remaining elements? The remaining elements are 2, minus 1, 4, 2. Now the rest is to expand it. Now it's been reduced from order 3 to order 2. Now it's easy to expand us, right? So let's consider the expansion from first row. So 1, open the bracket, 4 multiplied by 2 will be 8. This is a minus sign. So first always write down that minus sign which is here. Then you multiply these two. So 2 multiplied by minus 1 will be minus 2. Close it. The next element minus 3, open the bracket, multiply. This will be 4. So this minus sign I am going to write as it is. Minus 1 multiplied by minus 1, that is plus 1, but this minus is as it is. So close it. Plus 1 multiplied by, multiply the left diagonal, that is 4. This is a minus sign. 4 minus 1 multiplied by 4 will be minus 4. Let's simplify this. So this is going to be 1 multiplied by 10 minus 3 multiplied by 3 plus 1 multiplied by 8. Correct, right? Let us simplify this. So that's going to be 10. Yeah, that's minus 9 plus 8. Better we check is there anything where I went wrong. Okay, let me just see, check this one now. So that's going to be, so how much this is going to be? 18, and this is giving me 9. So I just want to check from the first row once again. So let me quickly do it. If I went wrong, then I should check where I went wrong. Okay, so 1 multiplied by 8 plus 2 minus 2 multiplied by 6 minus 2 minus 1 multiplied minus 3 minus 4. That's fine. So that's going to be 10 minus 8. Yeah, okay. And that's going to be minus 7 minus 1 plus 7. So 17 minus, yeah, sorry, it was wrong here. So the value of the determinant in first column, that's also going to be 9 only. See, in first row the value is 9. Even for the first column also the value of the determinant still remains to be 9 only. I want to just show you one more thing, the last thing. See, there are 3 rows and 3 columns. I did it for expansion with respect to first row, with respect to first column. Let me expand from second row. 1, 2, minus 1, 3, 4, 2, 1, minus 1, 2. Correct now? See, that happened because I used to block the elements, now rows and columns, so that somewhere the sign was missed out. Okay. So I said from the second row, minus, plus, minus. Right. Wherever you're expanding, you try to write down the signs on the top of it. It will be easy for us. So I want to expand from here. So this is minus 3. Leave the column and row. See, I'm not going to do that because I went wrong while doing it. It's an element of first column and second row. Leaving that, the remaining elements 2, minus 1, minus 1, 2. The next element is plus 4. Okay. Block the column and row in which 4 is present. The remaining elements 1, minus 1, 1, 2. The last element is minus 2. Leaving the column and row in which it is present. The remaining elements 1, 2, 1, minus 1. So let me expand and check the value, please. So minus 3 multiplied by, so the left diagonal 4. So write down, if you're getting confused, write down the sign on the top of the first row. So 2 multiplied by 2 will be 4. I'm writing this minus sign as it is. Minus 1 multiplied by minus 1 plus 1. But this minus sign on the top of it which is there has to be written as it is. Plus 4, open the bracket. Left diagonal 1 multiplied by 2, 2. So this minus sign as it is. Minus 1 multiplied by minus 1, minus 1. Clear? The last minus 2. So expand these two. Minus 1, minus 2. So let's go for it. Minus 3 multiplied by 3 plus 4 multiplied by 2 plus 1 minus 2 multiplied by minus 3. So that is minus 9 plus 2 plus 1 will be 3. That's going to be 12 and that's going to be 6. See, it is going to be what? Minus 9 plus 18. The value is still going to be 9 only. You expand it from any row or from any column, the value of the determinant remains to be same. But to do that, first thing I should know, what is the sign matrix? Okay, or what are the sign associated with each element of a square matrix? If I know this, it's better. Okay, I can go and expand it from any row or from any column. So for our convenience, let us always expand it from first row. Okay, fine students. So I hope by this time you're already familiar with what is a determinant. Okay, so every square matrix is associated to a particular real number. That particular real number is called as the determinant of the square matrix. Even I told you in the form of function also. If there is a function f from a to b, where a is the set of all square matrix, b is the set of all real number. If this has to be a function, every square matrix should be associated with a real number. Then only this becomes a function, right? Okay. So that real number which is associated to every square matrix, that is called as the determinant. Normally what we say actually, see, if a function is defined like f of x equal to y, we call it as y is image of x, correct? No? So here, okay, real number what is associated with a square matrix, that real number. See, this is a real number, right? The real number is associated to a square matrix. That real number is called as the determinant of the square matrix. That is all the definition. So don't get confused. A simple definition. Okay. So every square matrix is associated to a unique real number called as the determinant of that square matrix. That's all the definition you have to remember. Fine, students. So there are many illustration problems are being given in the EPL. So some problems are being given as worked examples also. So you can please refer and work out those problems. So I will mainly concentrate on NCERT part. The rest of the problems, everything is being given there. So there are problems where I am expanding from first row, where I am expanding from second row. Okay, you can expand it from any row or any column. The value still remains to be same. First thing. So worked examples are there. You can just refer them and you can just get the answer. Clear, students? Sorry, most of the time we will stick on to square matrix of order 2 by 2 and 3 by 3. Okay, we'll never study something called as 4 by 4 in our syllabus. Okay, or 1 by 1, something like that. No, that is not we're not going to do. So mainly we'll stick on to determinant of order 2 by 2 and determinant of order 3 by 3. Okay, these are the two things which you have to remember. And where it's going to be exactly used, that's another question. It's exactly used somewhere in finding the inverse of the matrix, in solving system of linear equations. Its main applications. Okay, its main applications are going to be finding inverse of a matrix, and it will help us in solving system of linear equations. Something like this. Now we have studied 3x plus 4y equal to 5, or 3x minus 2y equal to 7, something like this. We have studied how to solve. So we tried solving this by cross multiplication, by simultaneous system. There are many methods we have studied, correct? No. So apart from this, this will helps us also in finding area of triangle. These are the three applications of determinant, practical applications, where exactly it's going to be used. Okay, students? Okay. Now let's move on to NCERT exercise 4.1. Remember, students, I told you after differentiation chapter, before starting this relation functions, I said during lockdown session it's better to solve some simple chapters. Actually, this was not our sequence of teaching. Actually, our sequence of teaching were starting in the beginning. We wanted to concentrate purely on calculus, that is differentiation, integration, something like this. So that the student get enough number of revisions or enough number of tests based, or enough number of exams based on those. Okay, that is what the idea was exactly. But as you notice, it's an online class. So as those topics are very important, rather than these what we are studying, those topics are very important. That is actually your future. That is actually what you're going to study in your future studies. Okay, so what we thought was, it's not good to take the risk by teaching those topics in online. Okay, so instead of that, we have selected some simple chapters, something like this: relation functions, inverse, matrix, determinants. These chapters, with the help of one class, okay, most of you will understand. Okay, so let us come back to those important topics during the regular class. Now let's continue with this. Okay, so illustrative examples are there. You please refer, worked out examples you can refer. Okay, right. So let's concentrate on NCERT. The first problem: evaluate determinant 2, 4, minus 1, 2. I should evaluate these. They will never mention with respect to what. It's your wish. You expanded from first row, you expanded from first column, you expanded from second row, you expanded from second column. Nobody will ask you. Clear? Right. So for convenient, let's go for first row always. So what is the sign of the first row? Plus minus. So better you write down on the top of the first row. Right. So the first sign is plus. Right. Now what does the rule says? It says left minus right. Left diagonal minus the right diagonal. Correct? Now fine. So this is plus, so no need to write the plus actually. So just multiply these two. So 2 multiplied by 2 will be 4. The minus sign which is just above 4. Okay. Open the bracket. 4 multiplied by minus 1. That's minus 4. Clear? So simplify this. 4 plus 4 and that's going to be 8. So this 8 is the real number which is associated to this determinant. Clear? Right. The second example. Second one. X plus 1, x minus 1, x. We should expand this. So as usual on the top of the first row write down the sign. So first multiply these two. X multiplied by x will be x square minus, which is on the top of this, x plus 1 multiplied by x minus 1. What is x plus 1 multiplied by x minus 1? X square minus 1 square. A plus b minus, so a plus b multiplied by a minus b. So let us simplify. X square minus x square plus 1. Correct, right? So this 1 is called the determinant of this which is given. So let's go for the next one. Problem number 3. So in problem number 3, determinant delta they mentioned something. So determinant is going to be 1, 2, 4, minus 1, 3, 0, 4, 1, 0. Correct? Okay. So how to expand, from where to expand? It's your wish. I will take the first row always. So I will always write on the top of the first row the sign associated with the first row elements. So my first element is 1. Okay. Leaving that row and that column, what are the remaining elements? The remaining elements are 3, 0, 1, 0. That you have to write it in the form of a determinant of order 2 by 2. Fine. The next element is associated with the minus sign. So minus 2 open. Right. So just leave the column and row in which 2 is present. The remaining elements are minus 1, 0, 4, 0. The last element is associated with plus sign, so plus 4. Okay. Now leaving 4, leaving the column and row in which 4 is present. The remaining element minus 1, 3, 4, 1. The rest is to expand this determinant of order 2 by 2 now. So this is plus, minus, plus, minus, plus, minus. On the top of the first row again write down the signs. Clear? 1, this one I'm talking, right? Now 3 multiplied by 0, 0, minus 0 multiplied by 1, 0, minus 2, open the bracket, minus 1 multiplied by 0, 0, 0 multiplied by 4, 0, plus 4, minus 1 multiplied by 1, minus 1, because see plus into minus will be minus, so minus here, right? Okay. Now the next is minus, so first write down the minus. 3 multiplied by 4 will be 12. So let us simplify this. So these two elements are going to be 0, the last element 4 multiplied by minus 13, and the value is going to be minus 52.